Hello everyone. On behalf of Thinknix Technologies, I'm excited to welcome you all for another amazing video tutorial. Today, we're going to learn about the basics of Terraform. Before we get started, let me introduce myself. I'm Deepthi, working as a technical specialist at Thinknix. With more than 10 years of experience, I have delivered numerous trainings. I'm presenting this video that has been put together in collaboration with Mr. Yogesh Raheja. Thinknix experts have also contributed to several books published worldwide by Pact and Wiley publishers. In DevOps, we know that we collaborate, communicate, and integrate with various teams to build and deploy production-ready applications. But wait, where do we build our applications? Who will create and deploy the environments for our applications? The real challenge starts at the beginning where we set up an application environment. Let us understand the traditional infrastructure provisioning approach first. There are two teams, one for the application development and the other one for the infrastructure provisioning. The application team will request for various environments. Say for example, one would ask, hey, I need a DB server with Oracle pre-installed. The other one requests for 2 base Linux servers for his testing framework. And the third one comes stating that I need 3 servers with Tomcat on it, and so on and so forth. Now, these requests get raised following the ITIL standards, and the infrastructure team starts working on the requests one after the other. Request number 1 is catered to create a DB server, connection established with DC or cloud from our gateway server. And then starts the hassle of executing hundreds of manual steps from our notepad. Typically, a day gets over just to create a server, isn't it? And then comes request number 2 to create 2 base Linux servers. The same old repeated process gets followed with monotonous work. And the same will continue by performing tasks like server creation, application installation, file system creation, etc., with almost zero learning curve. This is what typically infrastructure teams used to do traditionally. Let us now understand what is IAC or infrastructure as code. When the infrastructure requirements were less, application upgrade routines used to happen once in a year. And the customers were happy without changing the legacy setup. There were no questions raised on the speed and agility for environments. But now, the business is changing at a rapid pace. Sitting idle waiting for environment setup for days is not a choice for teams who have high pressure from the customers for not only to deliver, but to deliver in a very stable and agile way. Stability, agility, and speed cannot be delivered by performing the tasks manually. Consider the same scenario which we understood earlier. Why can't we provision and manage our environment using simple code-based files? Instead of referring notepads, write something in an easy to understand way inside our files, place them at some center location for our entire team, and use them as and when needed. This way of writing code to provision and manage your environment by doing small or no change is known as IAC or infrastructure as code. Now, when I say code-based files, then that doesn't mean I'm referring to complex scripts which are imperative in nature. In the modern IT world, we prefer declarative approach where we just want to mention what is needed, and the how part will be taken care by the relevant tools. So let us understand what is Terraform. Terraform is an infrastructure as code tool for building, changing, and versioning infrastructure safely and efficiently. It was developed in July 2014 by a company called HashiCorp, which has also developed tools like Packer, Vagrant, Vault, Console, and Nomad. Terraform comes in two offerings. One is an open source, which is completely free to be used by anyone and is supported by a vibrant community. The other is Terraform Enterprise version with additional features like role-based access control, security governance, and official support. To write codes, Terraform uses its own language called as HCL or HashiCorp Configuration Language. HCL is declarative in nature and is very simple to write and understand. Terraform comes with lots of rich features. So let us understand some of the features and advantages of Terraform. The setup for Terraform is as simple as running a command and setting the same in your host path. Terraform is very light in nature and doesn't require intensive resources. Terraform uses HCL or HashiCorp configuration language to write Terraform codes which are declarative in nature. Writing these codes are much easier than writing complex scripts. Terraform codes are idempotent. So running Terraform code once or twice or any number of times will produce the same result. Terraform even has a planning step where it generates an execution plan. The execution plan shows what Terraform will do when you call apply. This lets you avoid any surprises when Terraform manipulates the infrastructure. Complex infrastructure need multiple resources to be used inside Terraform codes, and Terraform comes with intelligent dependency resolver which is inbuilt in it. This feature helps Terraform to resolve and arrange the steps without any intervention. Say for example, you wrote a step for creating additional disk before actually creating a server, then Terraform will automatically resolve the dependency and make the arrangements to build the server first and then followed by the disk creation. Terraform is platform agnostic, which is one of the most powerful features of Terraform. You can use Terraform codes on AWS, Azure, GCP, and on many other providers. There are some native cloud tools which does the same work like Terraform. Say for example, AWS CloudFormation, OpenStack, Heat templates, but they are all platform dependent. That's why it makes Terraform a strong contender for hybrid environments. Terraform's beauty lies in its simplicity and easy to use. And I'm sure most of you who have worked on CloudFormation or Heat template will understand the pain really very well. Apart from these, Terraform also have features like resource graphs, state files, enhanced workflows, and much more. You can go and explore more about them at terraform.io, which is the official website for Terraform. In this section, let us understand the terms and terminologies used by Terraform. So, how Terraform will be connected to your environment? How does it know if you want to provision for infrastructure on AWS or GCP? It does it by using providers. A provider is responsible for understanding API interactions and exposing resources. Providers generally are an IaaS like AWS, GCP, Azure, OpenStack, or PaaS like Heroku, or SaaS services like DN Simple, Cloudflare, etc. Once the provider is identified, it interacts with many provider resources which are supported by the selected providers. For example, EC2 for server creation in AWS, EBS for storage creation, etc. The main purpose of the Terraform language is in declaring the resources, which represent the infrastructure objects. All the other features exist only to make the definition of resources more flexible and convenient. Now, not adding hard-coded values in the code is the right option from the security standpoint. Obviously, it's never a good practice. Hence, you can variabilize the same using variables. Terraform also provides us the flexibility to perform post tasks on the created environments and support major players like Chef, Puppet, Ansible, Salt, and even traditional scripts with the help of provisioners. Filtering is always a must and great to have in hybrid code. This provides various options you want for different environments without creating codes over and over again. For example, if I want to use image 1 for a data center and image 2 for another without writing two separate codes, then data sources are exactly meant for this purpose. Extracting variables with their real-time values and rendering them directly for other integration is something which is taken care by outputs. As an example, extract the IP address of the newly created server and provide the same for your configuration management tools in your CI or CD pipeline will help you to have zero touch in your entire pipeline. What about reusability of the Terraform codes, especially if you have huge environments supported by multiple tools? Modules are a great way of sharing your code, which indeed consists of providers, variables, resources, provisioners, etc. Terraform codes are written with a special extension .tf, which stands for Terraform files. Now, let's understand Terraform code in action. Generally, as the best practice, we write majority of the Terraform code in main.tf. You can have any other name for the file, but main.tf is used in industry as a trend. Next comes the selection of the environment, which is under the provider block. The keyword is provider, followed by the provider name, which is AWS in our case, and we have enclosed this in the quotes. One major point here is not to include provider credentials like access key and secret key, as this is something which we will share on the global repository. Credentials in the code is a major security concern and is an open invitation to hackers. Next section is the heart of the Terraform code, which is defining the resources, which actually does the heavy lifting of creating various platform resources. In our case, we have used AWS instance resource, which will use the provider to make API calls to our AWS platform to create AWS instances. Similarly, another important section is the output block, which is used to calculate the key values, display them, and use for further integrations. All of the Terraform objects are associated with key value pair where the value is encapsulated in double quotes. Some of these values are mandatory and must be included in the blocks. We have used region in the provider section to select the region which is the geographical location to provision our resources. In resource section, we have selected two mandatory fields which are AMI, which is our OS image, and the type of the instance. We have also included an optional key value pair, which is an array to provide logical names to our AWS resources. And at last, we have calculated the outputs and displayed the IP created by the resource type, which is AWS instance in our case, followed by the name of the resource and followed by the key, which is public IP in our case. Thank you for watching our tutorial. We really hope you liked our video. Please do like and subscribe and click on the link below to know more about ThinkNext. Do let us know what topic you are interested to know next in our comment section below. Thank you, Abhiyanto. We shall see you soon in our next video. Stay tuned for more updates from us.